which one is greater? That will not tell us the kind of damping. You can have under damping. If R squared all over 4S squared is less than 1 over LC, that will give us under damping. That's the first possibility there. Okay, for R squared less than 4L over C, we have under damping. But if it is the other way, R squared more than 4 over C, we have over damping.
You are live, sir.
And then the
okay, me theory. I'm calling the corner last one bill. Okay.
They will join.
I'm ex salon, yeah.
Whether the amplitude is decaying rapidly or slowly, oscillation in the resistive circuit will always decay with time. Decay slowly over damp, decay very fast over damp. However, if the supply is now added now, if you had a supply such as like
same class, something, but want to sell.
They will join now. Hold on. They will join now.
Okay.
They will join
now.
Because you are bringing in an external input to sustain the oscillation. So when that happens, what is the nature of the new equation now? The new differential equation. So you have a natural frequency of the original system, and you have another frequency that is imposed from the external signal, the driver now. So this is the new circuit here. Okay, you can see that an AC source has been introduced. Why AC? Something that behaves in a similar way to the output of the system. The output is a decaying sinusoid. What we sustain it must also be a sinusoid. So we have introduced an AC. If the AC is assumed to be VT equals to V naught sin omega T, and the frequency of the fourth system is omega. The upper case omega. I told you last time that we have a lower case omega, we have the upper case omega.
Okay, what today? We're going to Saturday.
It will be equal to the first system.
Hello, everybody in the class. So we are hello. Can you hear me?
Good morning, sir.
Yes, sir.
Good morning, sir.
Yes, thank you for coming again. I want to share my screen with you. Let's see how I can share that screen with you. Where is it now? I'm trying to share the screen now. I'm at the day 200. Hello, I'm trying to share the screen. Can you see the screen?
No, sir.
Okay, first share screen. Oh yeah, hold on. We'll share with you. Click here.
Public class.
You are restoring
something the
at the particular point. For a given system, something
hello. Hello, sir. Hello. Me share screen. What you want online? Me share screen.
I think the host was mistakenly given to Fasasi.
Someone give me the half now.
No, I'm not
Just the half now, please.
Crying out
Please,
loud.
thank you. Just don't take any.
Don't leave, oh, I'm coming. I'm working on it. So that don't leave, I'm working on it. Hello, sir. Yes, I'll be with you now. I'm looking for my screen.
And SC they are equal. Okay, and from there, if you make your omega not the subject, you are going to get 1 over square root of the outcome for the operating system. Not that okay.
So, I'm actually your Fasasi. Fasasi, please remove yourself from host and turn it to me. I think they mistakenly put you as host. Fasasi, do that now so that I can share my screen.
Hello, ladies and gentlemen.
Fasasi, remove your...
Fasasi Enoch Oluwaseun. Fasasi Enoch Oluwaseun.
How should I do that? How should I do it, sir? How should I remove myself from the host, sir?
Right click. Can you see my own name? Bamidele Odimosu. Right click on my name. Click. Click on my name. Right, click on my name. Then you see a drop down. Click on make.
I've done that, sir.
You're already the host.
Okay, all right. Okay, thank you. You are not the host, sir. Dr.
Okay.
You are not the host.
Okay. So, class, good morning. Good morning, class.
Good morning,
sir.
Good morning,
Sorry
sir.
for the mix-up.
Good morning, sir.
Sorry for the mix-up.
Good morning, sir.
Yes, sorry for the mix-up.
Good morning, sir.
Yes, I have two screens to share with you today, and I want you all to enjoy the screen. Can you see the screen now?
Yes, sir.
Thank you. I'm still trying to see it from my end here. Okay, here you are with the screen. You remember we have taught temperature. We differentiate between heat and temperature in the last class. So I want to complaining to me. There's a lot of messages sent to me that they don't understand the calculation. So I have brought a lot of things in now. So listen attentively. So I'm going to share that screen with you, okay? So just give me some minutes. Yes, give me some minutes. I will share that screen with you. And I want you to just watch it. Okay, here we are. Okay, are you there now? Yes. We want to calculate this. A liquid in glass thermometer is graduated in millimeter. The upper and lower fixed point of the thermometer are 230 millimeter and 80 millimeter respectively. What is the temperature in Celsius when the thermometer reads 95 millimeter? I want you to write this question down along with the solution that we are going to watch now, and then continue to move, okay? From there, okay, now listen. Can you hear?
Yes, sir.
Yes, sir.
Get Agbani. Your guy, correction you. Don't subscribe, just listen and solve the problem. You see how the problem can easily be solved, okay? Are you with me now, everybody? Okay,
Yes,
go
sir.
ahead. It's one of the useful tools. The lower fixed point is 80 millimeters, and the upper fixed point is 230 millimeters. So we want to know the this is 0 degrees Celsius. Can you hear it?
No, sir. No, sir.
No, sir.
No,
We
sir.
can't hear it, sir.
Follow the calculation.
So can we hear it?
Yes, I know you. This one. How's this one?
C or X. Just follow the solving of the problem. Just follow the solving of the problem. Just write and follow it. It's as if you are calibrating the system. To calculate X, where we are.
Let's go to 15.
So you can see how you can calculate or calibrate your thermometer in standard form. Can you see it now? So
Yes.
this kind of a calculation must not be new to you. So I'm moving away from here to another thing now. The question is to be able to differentiate between heat energy and temperature.
Please hold on.
I should hold on.
Hold on.
So it's
Are you
a
still
simpler
writing?
method.
Are you talking to me?
Yes, sir. Please hold on, sir.
Okay, only can hold on.
I can continue.
Thank you.
Sir.
So yes, you have question
So
about it?
something.
Yes.
No. So is there a simpler method to this thing? So because
Well,
I read in a textbook, they said theta is equals to how theta
Sorry, are you
minus.
eating? Is there food in your mouth?
No, nothing is in my
can you
mouth.
allow her to talk, please? She's on the
Sorry,
floor.
sir, it is him.
Okay, see him. Allow
Yes,
him to
sir.
talk, please. Thank you.
So I've seen in a textbook that they said theta is equals to L theta minus L naught over
Actually,
L
there's a boy.
100 minus L naught times 100. So if
It's
you
the
use
same
it,
thing with this one now.
no, I'm
Hello.
just asking if it is advisable to use that one too.
See, when you want to calculate the temperature, all you need to do is to use this first scale. 100, which is the fixed point, and 0, which is the lower fixed point. The unknown is always by the middle. Okay? So now, since they are giving you in length, you can calibrate the unknown thermometer in that order. It's the same way we have done. It's just like a proportionality kind of calibration. Although there's still other method, but this is one of the simplest method that everybody in the class can understand. I don't want you to take you to another method. But if you solve your own problem and the physics is understood, then you are right. You understand now, class?
Yes, ma'am.
Okay, thank you. So we go to the next sharing of screen. In the next sharing of screen, I'm coming, please. Okay, here we are. That is last year's note. Now, are you there now? Hey, temperature depends on particle movement. You remember that yesterday? Is it yesterday or the day before yesterday?
On Tuesday, sir.
On particle movement. You remember I made mention of the particles of a system or a material vibrating about its main equilibrium position, right? So
Yes,
the
sir.
motion from the atoms give the object the energy. And because they keep on vibrating and they are so close, the vibration of these particles result into collision with the next neighborhood particle. And that will cause an increase in temperature, okay? Then the other one, remember for solid, where is it? For solid, particle will vibrate. That causes the heat flow. For liquid, atom will flow, particle will flow from one place to the other. And for gases, yes, they can move from one end to the other. Don't let me vibrate now, please. Don't mess up the class. Another temperature measurement is this. So class, convert, write it down, please. Convert 320 degree Fahrenheit to Kelvin.
Sir, please,
sir.
please,
Your voice is echoing.
mute themselves.
Somebody did
Mute
it. None of
yourself.
you should off it.
I'm sorry.
Yes, sir. Tell them to off their mics.
Off your mic. Thank you now. Convert 320 Fahrenheit to degree Kelvin. So I want you to practice it where you are now and tell me. Go ahead. If you are together, solve it together. If you are just on your own, try it and let's see.
Sir, please, can you repeat what you just said?
Convert 320 degree Fahrenheit to degree Kelvin. And I say you can work it together if you are seated together, and you can do it individually if you are all alone. So let me know your answer.
403.
Say that again.
403.
433 Kelvin.
Forward
433.
433 Kelvin. The first lady says forward.
433 Kelvin. Same.
Okay, it's the same thing. Anyone that, okay, if your answer is different from the one they are posting, can you tell me? If your answer is different.
I
Okay.
didn't get it.
You didn't get the question. The question says, convert 320 Fahrenheit to Kelvin.
433.
Okay, thank you. Now, the second one is this, that you should convert, no, I will say it in another way because you might likely see this kind of a thing somewhere along the line. That a temperature scale shows that the upper fixed point is 200 ohms. And the lower fixed point for the same thermometer is 90 ohms. Now the question is, what will be the temperature in degree Fahrenheit if the thermometer reads 120 ohms? Again, what will be the temperature of that material if the thermometer in question reads 120 ohms?
Sorry, Sebs, can you come again from the beginning?
A resistant thermometer has a fixed point of 200 ohms. For upper fixed point, the lower fixed point of this same thermometer is 90 ohms. When this thermometer is used to measure the temperature of a material, it reads 120 ohms. And again, what is the temperature of this material in degree Fahrenheit? What is the temperature of this material in degree Fahrenheit?
It's 1.1.
Wait now. And 2, in degree Kelvin. In degree Kelvin. What you needed to do is to follow the example that you have before. Draw the line to the upper fixed point of your normal temperature, 100 and is 0. Put C in between. Go ahead.
Yes, sir, I got 27.3.
In Fahrenheit, it's 81.09 degrees Fahrenheit, while in Kelvin, it is 300.27.
It's
1.09 degrees Fahrenheit.
Okay.
Then in Kelvin, it is 300.27.
300.27 Kelvin. Okay, just hold on.
So I got the same thing now.
You got Kelvin, the same thing with him?
Yeah, in Kelvin,
okay.
300.27
okay.
Kelvin.
I want somebody to prove them wrong. Is there anyone that got a different result? Oh, yeah, talk now. Is there anyone that have a different result? Nobody. Is there anyone that cannot solve this problem?
No, sir.
Yes, I cannot solve it. No, sir.
I cannot solve it. Since you cannot solve that problem,
I don't understand.
say that again. You cannot solve it. Can I hear you?
Yes, sir.
Yes,
You
sir.
can't
Yes,
solve
sir.
it.
Yes,
sir.
I did not hear the answer.
I said
Can you
draw
explain
a
us?
line,
I
a
was
straight
getting
line.
something entirely different.
Please,
Say
what's
that
the
again.
answer? Like, I did not get the
Sir.
answer.
I don't want two people
get the formulas
talking
for
at
me
the same time. This is a class. If I don't say talk and you talk, I may be annoyed with you. And when I'm annoyed with you, you will not love it. So, Adeniran Abdulatif, it's your turn to talk. It's no more there. Okay, Mayowa Ayeni, it's your turn to talk.
Sir, I did not understand.
Sir,
Okay.
for the Kelvin, I got 300.27.
Who is talking? Who is talking?
Mayowa.
Okay. Mayowa, you did not understand it. Is that the question?
No. I said for the Kelvin, I'm having 300.27 Kelvin as my answer.
Just say your answer is the same thing. Salamat, you have the floor.
No, sir. So
Are
I
you
did not
okay?
quite hear the answers. I did not hear the answers.
You did not get the answer.
Their own answer. I did not hear.
What is your own answer? What is your own answer?
86 Fahrenheit and 306 Celsius.
You got 82 degrees Fahrenheit.
86.
86.
Yes, sir.
Okay. What I want you to do is this. Draw two parallel lines like we did previously. In one,
Yes,
so
sir.
100 degrees Celsius. And so at the lower end, so is 0 degrees Celsius. The in between two of them, let it be 6 degrees Celsius. Then draw another line, which the second parallel line, the upper fixed point is 200 ohms.
Okay,
and the lower fixed point is 90 ohms. The temperature of the material is 120 ohms. Now you have two identical thermometers with you there. So what we needed to do, subtract the lower fixed point from the temperature of the material. In other words, I'm saying 120 minus 90. Then you're going to divide whatsoever you obtain there by subtracting the lower fixed point from the 200. Then you do the same thing to this guy. X minus is 0 all over 100 minus is 0. Equate it together and try to solve the problem. That becomes an arithmetic somebody in JS2 can solve. Are you okay now, Abdullah?
No, sir.
Okay.
The answer in Fahrenheit and
no, yes, that answer we give you in degrees Celsius.
Yes,
if you want
sir.
to do it in degree Fahrenheit, then we can do it directly by saying the upper fixed point is 213, I think.
No,
Sorry, 212, 212.
Yes,
and
yes,
the lower fixed point is 32 degrees Fahrenheit. So the middle, put F. So again, it's going to be F minus 32 all over 212 minus 32 should be equal to 120 minus 90 all over 200 minus 90. So that becomes a simple arithmetic for you to do.
Yes, sir.
Thank you. So we move ahead. Uche, pretty Uche, you have a question now. Uche, you have the floor.
I don't have anything.
I can't, don't use bedroom voice. We are in class.
Hello, sir. Can you hear me, sir?
Okay, who is speaking? Uche?
Yes, sir.
Okay,
so I want to ask, sir, instead of us doing lower minus the one that is down, Can we do upper minus lower over middle minus lower?
Whatever you are doing, whatever you do to the come inside, whatever you do to the thermometer must be reciprocate to the standard thermometer you are working on. So in doing that, you have to do the same thing to both thermometer so that you can get the same result.
Okay, sir. Okay, sir. Well understood, sir.
Okay.
Thanks, sir.
Okay.
Excuse me, sir. We cannot hear you here.
Okay, cannot hear me. Okay, now. The next one is how does a thermometer work?
Sir, your voice is echoing. We cannot hear you.
It's not echoing here.
Sir, your voice is not echoing, it's your side.
It's because
how
of
does
the
a thermometer work?
unmuted.
Remember, I made mention of thermometric properties.
Sir, we can't hear you.
I made mention of thermometric properties of different materials in the class. Remember that? You are talking now. If I get you, you will fail automatically. You talk or what is your name? If I get you, you will fail automatically. I'll just get your matric number. Leave the class if you want to go and talk. So how does a thermometer work? Remember, we made mention of thermometric properties in the last class. Thermometric properties. We made mention of different thermometers in that class. Don't forget. What are the thermometric properties of a liquid in glass? Can you tell me? Thermometric property of liquid in glass. What are they?
Length of the
Length.
liquid.
The length.
Length of what?
Length of the thermometer.
Length expansion.
Sir, mercury and alcohol.
Length of the liquid inside the glass. The length of the liquid inside the glass changes as the temperature changes. Show, who is this one? Is it Olopade now? Oladipupo? You have the floor. What's your question? Oladipupo, you have the floor now.
All right, sir. Good afternoon, sir.
Sir,
about the questions, I just joined the class now. Can I see the questions?
You just joined the class. Okay, line up there. We'll come back to you. We'll come back to you, okay? Now, it is the length of the liquid in glass that will increase when the temperature increases. It is the length of the liquid that will contract when the temperature contracts or reduces. So therefore, the change in temperature or the thermometric property for liquid in glass is as a result of change in the length of the liquid within the glass. Mention 3 types of thermometers you know. What are they?
Mercury.
Liquid in glass thermometer.
Consistent thermometer.
Over 3. 0 over 3. 0 over 3. 0 over 3. There is nothing like mercury thermometer. In the last class, I did not say anything like that. Okay, somebody is talking and wait, hold on, class. Pasasi Abdullah, it's your turn. Go ahead.
Liquid in glass thermometer.
Liquid in glass thermometer. That is it. And when you talk about liquid in glass thermometer, we have two types of liquid in glass thermometer.
Your voice is echoing.
Mercury in glass thermometer, and we have alcohol in glass thermometer. By now, if you differentiate between the two or state the advantages of one over the other. Okay? Remember, the exam is going to the CBT. It's either you know it or you don't know it. Emmanuel, you have the floor.
is coming from Shukrat.
Emmanuel.
Yeah, mercury thermometer.
There's nothing like mercury thermometer. It's mercury that is liquid in glass thermometer. So you can now say the liquid now is mercury. It must be in that, okay? Because it's multiple choice you are doing. Yes, if it is theory, you just wrote mercury in glass, okay, a mercury thermometer. We may let it go, but just be aware of that. Akinyemi, you have the floor. Okay, that is Emmanuel. Thank you. Divine, Nwachuku, you have the floor.
What are the types of liquid in glass thermometer, sir?
I made mention of mercury and I made mention of alcohol. And I told you mercury is used because mercury had a lot of advantages over alcohol. And I told you by now, you should be able to know the advantages of mercury over alcohol. Thank you.
Right, sir. Thank you.
Chuku Funaya, it's your turn.
Okay, we have resistance thermometer and infrared thermometer.
You. Resistant thermometer, which is called platinum thermometer. Very good.
Thermocouple and infrared thermometer.
Thank you, thermocouple and this. I'm going to send you the slides of yesterday or the previous class if you are patient. Or you already have it?
No, sir.
Okay, you are going to have it today. You are going
No,
to have it today. Oh, yeah, we are going to have it. Oh, yeah, go ahead.
Thank you, sir.
How many types of thermometer now? How about
That's 4.
Okay, go ahead.
That's all I know.
Okay, Onoja, how about you? Marvelous Onoja. Clinical thermometer. Yes, that is, when you say clinical thermometer, it is localized because clinical thermometer makes use of the mercury type of liquid in the glass. Don't forget about that. I was thinking you are going to say constant volume gas thermometer, constant pressure gas thermometer. You've forgotten. Onoja, marvelous. You have the floor. Onoja,
but they've mentioned everything. They've mentioned
everything.
And
I believe
thermometer.
put it down too. Okay. Lastly, what are the differences between heat energy and temperature? The differences between heat energy and temperature.
Sir, heat energy can do work, but temperature cannot do work.
All right.
The unit of heat energy is joules. The unit of temperature is Kelvin.
Is measured in calories.
Okay, thank you.
Temperature is measured in Celsius and Kelvin.
Is that Treasure speaking?
No.
Basi.
Temperature is a scalar quantity.
Temperature is a scalar what? What do you say?
Temperature. It's a fundamental quantity, sir.
Fundamental quantity, yes. What happened to it?
Heat is transferable, while temperature is not transferable.
Who said that? Can you explain?
Heat is a vector.
Hello, sir.
Temperature has no direct.
Temperature can be defined.
Flows from high to low.
What's your name?
Temperature can be defined as the average kinetic energy of the molecules of a substance, while temperature is related to the energy of movement of the molecules.
Thank you for reading it from internet to me.
Temperature.
Yes.
Temperature is the average kinetic energy
Measured
of the
in
molecule.
Okay, above all,
temperature is measured in Kelvin.
Sir, it's minus, so it's not.
I have the
If
floor
energy
now.
is
I have the
transferable,
floor
sir,
now.
sir,
I have the floor now.
Temperature is measured in
Excuse me.
thermometer.
Sir,
Excuse
I
me. I
want to
have the floor now.
explain that
Listen
if
to me.
energy is moved.
By now, you must be able to answer all those questions. You must be able to answer all those questions at the end of these slides, okay?
Yes,
all right? Okay. So I'm going to send you the slides. You must be able to calculate and do conversion of the units of temperature. And you must to answer one or two problems with respect to that. And finally, let me just give you one question, take home question now. All right? Are you ready?
Yes,
Yes,
sir.
sir.
Yes, sir.
Just give me 1 minute. Let me look for it.
Yes,
Okay,
sir.
sir.
Okay, here we
Yes, sir.
are. What is the lower fixed point of Kelvin scale?
Minus 273 Kelvin.
I say, wait, I see
Calm
your
down now.
question.
The
It's your
assignment.
question. Then number 2,
273.
convert 176 degrees Fahrenheit to Celsius. Number 3,
Sorry,
convert.
sir, please. What was the first question?
The second question.
They said it's up for by you asking questions.
I've forgotten that one. So let's move ahead. The next
Huh?
question now.
176
Convert
what?
37 degrees Celsius.
Calm down now.
Convert 37 degrees Celsius to degree Fahrenheit.
Are we to submit or just playing
No,
crossword?
just to practice. You don't have to submit, just to practice. What are the thermometric properties of thermocouple thermometer? Just put it down so that you can look for it. The thermometric properties of a thermocouple thermometer. Then number 3, state the thermometric property of resistant thermometer. Resistant thermometer. Differentiate between constant volume gas thermometer and constant pressure gas thermometer.
Now come again.
Differentiate between constant volume gas thermometer and constant pressure gas thermometer. Class, I'm going to stop here today because we're going to go and prepare for Jumite so that we can go and pray that so that we can pass. Prepare yourself. After the prayer, you will see the slides already in your system, okay?
Okay, sir.
Okay, sir.
Any question again?
No, sir.
See you
Yes,
next
sir.
week.
Second assignment.
Thank you. Bye-bye.
Yes,
Sir, pay for
sir.
The assignment.
Yes, don't submit. Keep it to yourself.